Good morning, everybody. This is EE391, MM391. Welcome to Maintenance, Reliability, and Engineering Economics. Welcome to this morning's lecture. We are in week 12, lecture number 3. This is week 12, lecture number 3. Now, before we move on, can I please request students to enter your name and student ID in the chat box, please. Okay, please enter your name and student ID in the chat box. Okay, now the major announcement is that we will be having a short test next week Friday. We will be having a short test next week Friday, and the short test will be available from 10 o'clock. Sorry, would you? I just wanted to inquire. Would you like to have the short test in the morning, or would you like to have the short test in the afternoon?
We have it on the lecture time.
You want it during the lecture time? Okay, I can have it available in the lecture time. And what I'll do is I'll allow the portal to be open for 1.5 hours, so the portal can go from 10 o'clock till 12 o'clock, and I'll be available online if you want to, on Viber and on Zoom, and you can drop in and ask questions if you have any query. But it will be on Moodle. Basically, you have to do some calculations and enter your answers. No, there won't be any scanning. You will enter your answer. We won't require to see any working. You'll be just required to enter the answer into the answer boxes. All right. There will be some answer boxes. Like, for example, I'll ask you. I'm just giving you an example. Like, for example, I'll ask you, what is the future value of $1,000 in 5 years at interest rate of 2%? So you'll calculate your answer and you'll put your answer in the thing, and then you'll go to the next question. All right, submit your answer into the answer box, and you'll go to the next question. I don't want you to scan and upload or anything. Right, the percentage for the test is 6%. We can I can open the, if you want, I can open the portal. See, what I was suggesting is I will open the portal from 10 o'clock till 12 o'clock, but the test in itself will be just 1 hour. So somebody can, for example, come in at 10:30 and then finish at 11:30. The test is 1 hour, but the portal, the availability is from 10 o'clock till 12 o'clock. Yeah, so Amit, can you just clarify what this? You have another class at 11. Oh, okay, you have another class at 11, eh? Okay. All right, fair enough. I can open the portal at 9:30. What class do you have at 11? Amit? EE362. What class is that? Advanced digital control. Oh, okay. Yes. Okay, so a few of you guys are doing EE362. All right. Even what I'll do is I can make the portal available from 9:30 till 12:30. All right. And it'll be very simple questions. One or two hard questions, actually. Some questions broken up into pieces. I may ask you, if you look at our examples, we are doing some heavy duty problems in our examples as well. All right. Okay. Yeah. Okay. So next week, 9:30 till 12:30, the portal will be available. Right, 3 hour session, 3 hour portal, but your test in itself will be just 1 hour. So when you log in, you're supposed to finish within that 1 hour. All right. Okay. Yeah. Um, all right. So there will be a 3-hour portal, but you know, you can do the test for 1 hour, and basically you need to be ready, right? You need to enter your thing, and the other thing is, I'm going to make the questions in such a manner that nobody will be well, it'll be all calculation based, everything from engineering economics. The test will be everything from engineering economics. Test weight is 6%. I might planning to bring it to 7%, but let's see how the performance is. But 6% at this point in time, it's 6%. Um, um, uh, you do your calculations, everything from engineering economics, nothing from maintenance and reliability. You'll do your calculations and you enter your calculation into the enter your answer into the box. Okay, and there'll be a number of questions. There'll be a number of short questions. So you have to be ready with your calculator, your exercise book, and you should do it very quickly. Okay, all right. Um, okay, let's start today's lecture, guys. I want to share my Microsoft Word document.
See, we can have the feedback write up how much we get for each week.
Oh yes, okay. I'll get that done. Um, yeah, I think the tutors are slightly behind. We'll chase them up. But guys, generally, don't worry too much about the write up, because what I can assure you, if you have done if you have submitted something, you'll almost certainly get the mark in the write up, right? It's not like you'll get there's no right or wrong answer in there. So long as you've covered the notes, you're good to go. You have received your mark. Right, so just in the back of the mind, keep that in mind. So it's a very easy mark which I've given you, right? But all right. Anyway, okay. So we are on week 12, lecture 3. We did this very big question, which was comparing device A and device B. Especially when it came, device A was quite straightforward, but when you came to device B, you saw how things could get complicated, right? And then in question 6, we were looking at present worth analysis to compare a number of different lathe machines. Now we move to question 7, right? And this is week 12, lecture 3. The date is 12th November, week 12, lecture 3. All right. Okay. All right. Let's have a look at this thing. Payback period. I'm pretty sure you've done some studies on payback period when you were looking at MM391. You know, we had to do some studies on renewable energy, and then you have to look at payback period. All right, now let's have a look at this. Building a bridge will cost $65 million. A round trip toll of $12.
There's nothing on screen.
There's nothing on screen. Thank you for letting me this know. Screen is paused. All right. Why did the screen go to pause? Let me just reshare. Let me reshare. Okay. Can you guys see the screen now? Hello?
Yes.
All right. Okay, nice. Thank you. All right. Guys, when I'm speaking on the other side, are you able to see a picture of me speaking in the corner or something?
Yes.
Oh, okay. Set. All right. Okay. Building a bridge will cost 65. So today is 12th November. It is week 12, lecture 3. Building a bridge will cost $65 million. A round trip toll of $12 will be charged to all vehicles. Traffic projections are estimated to be 5,000 per day. The operating and maintenance costs will be 20% of all toll revenue. Find the payback period in years. All right, it's a very simple problem. All common sense over here. You don't even need to know engineering economics. Your mathematics background will be able to assist you. Okay, so so no formulas over here. Okay, initial investment is equal to how much is that? 65 billion. All right. Okay. Next, what is the round trip cost? Round trip, which means round trip means like when you make a round trip to Nosori, that means you go from Suva to Nosori and then back. Round trip means both ways, both legs, 2 leg and return leg. All right. Okay. Round trip is equals to $12 per trip. Okay. How much is the traffic? Traffic is equal to 5,000 vehicles per day. All right. Revenue. Okay. All right. We stop over here, guys. In Fiji, we are lucky, and in the Pacific, we're lucky. We don't get this toll. Let me explain to you the concept behind this toll. In overseas, the way they, especially in developed countries like Australia and New Zealand, the way they fund their infrastructure projects is, let's say, if they put in a new road, let's say from they put in a new 3-lane road, right? So every person who uses that road will have to pay a particular fee. They pay 50 cents or $1, right? And in the end, that revenue is used to pay off the road, or it is used to make money, right? So in fact, that plan was that was going to happen in Fiji as well. If it wasn't for COVID, because now in COVID government has stepped back from all the things, they were going to slowly invest in make the Suva-Nosori highway, the Suva-Nosori arterial road, a toll road. So anybody uses it has to pay 50 cents per use. All right. So you can imagine the number of vehicles using it per day and the resulting final amount, right, of revenue per day, right? And then that way they are able to get revenue back, because they put in so much money into the road, and then they are able to use that money for maintenance as well. All right. Okay. So that's how a toll works, and they use it overseas. They build tunnels. Like for example, if you want a direct route to go from Suva to Lemi, if you want to cut from Suva to Lemi right now, you have to go through Suva town, right? If I want to go from Lovala Bay to Lemi right now, I have to cut through Suva town. So what they do is they put an underground tunnel. And then you pay for the toll over there. So that's how things work overseas. Okay, some question from Mr. Amit. How would they determine who uses it regularly and who uses very little? No. It's like when you enter, there will be an entry point. And at the entry point, you have to put your coin in the bucket. At the entry point, you have to put your coin in the bucket, and yeah, that's how they do it. So yes, for every trip. I've got a cousin who lives in Sydney, and he travels. He uses. Okay, so it's like this. Check this out. I don't know if any of you guys live in Nakasi or Nosori area. Anybody over here on our participant list living in the Nakasi or Nosori area? Anybody been to Nosori? So right now there's 3 ways to go to Nosori. Firstly, you can go to Nosori via Princess Road. Secondly, you can go to Nosori via King's Highway. Thirdly, for half of King's Highway, you can bypass and you can go via the Nandawa way, via I think it's called Ratu Dovi Road, right? Okay, so the fastest way is probably the King's Highway, or because it's got 2 lanes. So if you catch the other roads, you might take 1 hour in peak traffic to reach Nosori, right? Even though the distance is only 12 miles, it takes 1 hour due to the heavy traffic. So the people who would pay for King's Highway, they would get to Nosori within 15 minutes, right? So I've got a cousin who's living in Sydney. he pays 37 Australian dollars per day. 36 Australian dollars per day in toll. $18 one way, $18 back. Because when he uses the toll, he gets to his work within 25 minutes. He uses all the tunnels. You know, he uses 2 or 3 different tunnels, and each of them is like $4. Another one is $5. Another one is $6. Something along those lines. And if he was not to use the tolls, if he doesn't want to use the tunnels, it would take him 2 hours to get to his workplace. So this is how the reality of the situation is. All right. Okay, so let's do this problem. Initial investment is that much. Round trip is this much revenue. So revenue would be basically how do we calculate revenue? So it's 5,000 vehicles multiplied by $12 per trip, which is equal to how much, guys? What do we get? 5,000 vehicles multiplied by $12 per trip. Revenue per day.
60,000.
Yes.
60,000.
60,000 per day. Per day. All right. Okay. Okay, that's the revenue. Now operations and maintenance. Operations and maintenance is equal to, what does it say? Cost will be 20% of all toll revenue. 20% of revenue. All right. Which is equal to 20% multiplied by how much? 60,000 per day. And how much do we get, guys? Yes, 12,000 per day. Remember, we have to look at the timeline per day. All right. Okay. So let's look at now the surplus. Surplus is equal to, what is the surplus equal to, guys? Surplus is equal to revenue minus surplus is equal to revenue minus expenses. Right? Simple. I mean, these are not formulas which I need to teach you. You should know this already. Okay. So revenue is 60,000 per day minus the thing is equal to that much. What do we get for our thing? Yes, thank you. 48,000 per day. Remember, a lot of you guys are not putting your day per day answer. Right. Okay. Now, let's now convert the surplus into an year. How many days per year? $365 days per year, which is equal to what is the revenue per year? Okay, and can we convert that into billions, Amit? What do we get? 17.52 million per year. So that's how we deal with it, because you know this is $1 million project. So obviously we're going to do $1 million project, right? I mean, we have to deal with things in million. Now payback period. Payback period is equal to initial investment divided by surplus, which is equal to $65 million divided by, and what do we get, guys? 3.71 watt. What's your unit? Yes. Simple question. Simple stuff. All right. Okay. Okay, let's now move to the next level. Okay, assume for let's do problem 7 part B. Assume that a loan was taken. Assume that a loan was taken from a international bank, to fund the project. The interest rate is set at, let's say, 5.5%. Right? What would be the payback period? All right, now I want you to give this some thought. This is not as simple as it looks now, right? So I did this particular initial part of the question just to help you guys out to understand the concept of payback, right? By the way, did you guys study? Can you help me out over here? Did you guys study payback period when you did this course EE301 MM301? Was there anything on payback period? Hafiz, Bhavish, you guys are there? Anybody else? Amit? When you did 301? John? E301, MM301, did you guys study payback period? Not that I remember. You guys just did it last year. How can you remember? Not forget. Anybody else? Anybody remembers? Bhavish? Is Bhavish here? No. Hafiz? Alright. No, you guys didn't study this. Okay, so we'll study this. Okay, anyway, that's the simple concept behind payback period. Okay, now I want you to now think of what is our unknown. What is our known? I mean, what is our unknown? What is known? What is known, guys? Well, our P is known. What is P equal to? P is equals to 65 million. P is equals to 65 million. What else is known, guys? I is known. Yes, I is known, and that's 5.5%. Right? And what else is known? A. Where does the A come from? Well, P was the initial investment, right? Because you need that much money to do your, you need that money, you need to take the loan. Your I is set by the bank. Your A is what? Your A is your surplus. Surplus, which is equal to 17.52 million per year. Right, 17.52 million per year, because we have to look at it in years. All right. Yeah. All right. And so what is unknown? n, which is your which is your payback period, which is time, which is same as payback period. All right. So what formula suits this particular situation? What do we use? Okay, we can use P given A, right? Yeah. We can use either, we can use either P given A or A given P. All right. Okay, so let's now use, yeah. All right, so let's now consider P given A. Okay, so in this slightly different situation now, because our n is unknown, right? Now P is equals to 65 million. A is 17.52 million because we're dealing in years, right? Interest rate is 0.055. 0.055. Your n is unknown, and your n is unknown. Now, tell me, I mean, we're engineers, is this solvable? Would n be solvable? Try it. I'm going to give you guys 2 minutes. Tell me, is n solvable in this scenario? No. There is no way to make, if we observe the above equation, there is no way to make n the subject of the formula. There is no way to make n the subject of the formula. All right, so we are stuck. So what do we do? So let's this approach. So we use the interpolation approach. Okay. Okay. So we use the interpolation approach. This is a mathematical approach, right? It's very simple, guys. It's very simple. Now, let me give you a side example. Let's now consider the pure math. Consider the pure math a basic math problem where 2 points are given, right? Okay. 2 points are given. P1 equals 1, 1, and P2 is equal to 9, 7, right? Okay. find the x value when y would equal to let us say 5. How would you do this problem, guys? I'm not going to do this problem for you. How would you do this problem? Let's discuss. The whole idea of me giving this problem was not to teach you guys high school mathematics, but more so to generate some discussion. How do we attempt this particular problem? We've got 2 points on a plane, right? We've got P1 is equals to 1, 1, right? And P2, consider 2 points are given, and 2 points are given which form a line. Find the when y on that line. Yes, yeah, okay. Basically, we find the equation of the line, right? We find the equation of the line, okay? And I mean, we find the equation of the line, and what we do is once we find the equation of the line, we plug in our we try and find, because y is given, right? We want to find x. We want to find x, and y is given. So what do? We have to work backwards. We have to work backwards and find exactly where on that line will 5 occur, right? Because this is a linear line. If you look at this line, right, the line is linear. It's a straight line, right? The problem is that in our problem, in this particular equation, the line is not straight, right? So the way we would solve this particular problem, if this was not a linear line, was one simple way. A simple way would be a simple approach. Okay, since the above is a straight line, we can use y is equals to mx plus c. But if the line were non-linear, like what we have in engineering economics, we apply a very simple approach using a table as follows. All right, so let us say this is x and this is y. All right, we know 1, 1, so let us start from 2. Three, 4, 5, 6, 7, 8, 9. Okay, we don't need 9 because for 9 we already know it's 7, right? For 2 we already know. For 2 we already know that it will be. Oh, okay, for 2 we don't know. So first we find the equation. What is the equation of this line? Guys, what is the equation? Can somebody deduce the equation for me? What is the y is equals to mx plus c for this line, if it's a straight line? y2 minus y1 over x2 minus x1. That gives you your m. What is your m? M is equal to m is equals to 1.33. What is your c? Guys, you should be very familiar with this thing. This is almost like high school level. What is your c? Okay, I trust that the student is correct. So y is equals to 1.33 m plus 1.33 x plus 5.25. All right, because c occurs when x equals 0, right? Okay. Anybody else can confirm that? Amit, anybody else? Is that equation correct? All right. Tavaki, 0.75x. Hey, anybody else? So we've got two different answers. Okay. (0.75x) plus 1.33. Okay. All right. Now, let us say if it was a very complicated. This is a very simple question. I made our example very simple, but we will soon answer this particular problem. All right. Okay. Now, normally what we would do is, in order to find x, all we have to do is we have to plug in y equals 5 and find x. But if it was an unsolvable equation, then how do we do this? So we plug in different values of x. Let's plug in x equals 2. What do we get? Guys, if we plug in x equals 2, what do we get into this? What y do we get? Come on. X equals 2. 2.833. X equals 3. X equals 3. (3.583). X equals 4. We are approaching 5. Can you see we are approaching 5? Okay. All right. Now we don't need to. Oh, okay. X equals 4. We have that much. Now, can you see that 5 would sit? 5 is somewhere between 3 and 4. We don't need to do all of this anymore. We can delete all of that. Okay. So I'll leave it blank. We don't need to do all of this, right? So I just put a coloring over there, right? So now we know that it is between. We now know that the particular what do you call the particular x value, exact x value, sits between 3 and 4. I know most of you have gone and calculated the exact value, but what I want to show you is I want to show you the concept. So we know that it's sitting between 3 and 4, and there's a big gap between 3 and 4, right? So what we will do is we will put this here, and we'll put 4 over here. Then what we do is we put 3.2, 3.4, 3.6, 3.8, and 4. Okay, so this is an iterative process. Remember, the catch is this: a lot of you have gone ahead and calculated. By the way, has somebody calculated the exact value of x? What is the exact value of x? guys? You guys would have made x the subject of the formula. If you make y 5, then the exact value of x is equal to, for when y is equals to 5, exact value is equals to 4.88, okay, 4.889. all right, but I want to show you this iterative process, right? Simple approach using a table as follows. Please note that this is an iterative process. Okay, this is an iterative process, right? Okay, now 3.2. Can somebody put in 3.2? Oh, 3.2 is this much. Lufkesh, thank you. Okay, that was 3, right? 3.2 is 4.33, is that correct? Okay. I should have demonstrated this on Excel, maybe it would have been faster, eh? But anyway, I think Lufkesh is using Excel or Matlab. What are you using, Lufkesh? Excel. Nice, I like Excel. Right. How did 4 end up at... That means there was an incorrect answer over here. No? What was the value when you inserted 4, guys? Okay, 5.083. So that means this answer is correct. This answer is incorrect. 5.0. What is the value of x when 5 when y is equal to 5? Because it goes from 2, 3, and then it's 4.899. Okay, what was the value of 4? Okay. Oh yeah, there we go. So that should be, when you input 4, the answer is 4.33 or 4.899. 889. 4.33. Right. And 5, when you enter 5, what do we get? $5.083. All right, don't worry, I can repair this. Okay. So these gray blocks over here mean that we don't need to solve for these 3 steps. All right. Now, so because now we realize that it's between 4 and 5. The 5 value is between number 4 and number 5. So we have to do this. 4, 4.2, 4.4, 4.6, 4.8, 5. Now, what do we get? For 4, we get 4.333, 4.333. What do we get for 4.2? Punch it into Excel, guys. Okay, for 4.2, yes, we get that. Okay, 4.4, 4.4, 4.4, okay, 4.6. So it's going to be very close. Don't do 4.6, do 4.8. Okay, right, okay. You've done 4.6, that's all right. Do 4.8 now. I was going to say it's close to 5, right? Okay. Okay. All right. Oh my God. Okay. Tamaki. All right. The value, okay, anyway. What is the formula? It's Okay, never mind. It's all right. We'll continue. We'll continue. It's okay. We'll continue. All right. So we've got it till 5, and Tavake is saying the equation was wrong. The equation is plus 0.025. Okay, guys, can somebody quickly do this on Excel for me? Or I'll need to open Excel. Can somebody find me? So this let's ignore all of that. Let's ignore all of that. Let's ignore all of this right now. All right. Can somebody find me these values? So these values are invalid now. Now, can you put 2 into Excel? Who's doing Excel? I'll open my Excel as well. Just give me the whole range, guys. Okay, so that's 2, 3, 4, 5, 6, 7. Okay. Oh no. So it'll be 2.5, 3.25, 4, 4.75, 5.5, 6.25, 7, and then 7, and then what's for 9? Okay, everybody getting different answers, man. Let me just do this myself. Guys, is this equation correct? 0.7x. I'm just doing this on Excel. There we go, Excel. Right? Okay. All right. So where does our 5 sit? Our 5 sits between 6 and 7. Right? So we find that 5 sits between 6 and 7. All right? So therefore what we do is we put 6, 6.2, 6.4, 6.6, 6.8, 7. Right? Okay. Now, let's now do this over here. Let me now just get that. So sits between 6 and 7. All right. 5 bits sits between 6 and 7. So just color, and then it sits between 6 and 7. So I'm going to highlight those two as pink so that we know that it sits between those two, right? So I know, Amit, this should be 5.05. That's our exact answer. But remember, in our particular situation, we are trying to find it iteratively because we can't do subject of the formula in this particular problem. So I want to show you the tabular method. Right, I'm going to put this in Excel 6.2, right, 7. So there we are, between 6 and 7. Oh, there, okay, all right, set. So now what does it sit between now? Where does 5 sit between now? It sits between 6.2 and 6.4. So we do another iteration. Iterative process means you have to do multiple steps. All right, it means we have to do multiple steps. Now 5 sits between what? 6.2 and 6.2 and what? and 6.4. So now what do? We rub that off. We do 6.22. Okay, rub all of this off. We do 6.22. We do 6.24, 6.26, 6.28, 6. 6.3, 6.32, 6.334. All right. 6.36, 6.38, 6.4. So we now know that it sits somewhere in the middle of that. All right. Okay. All right. I know he's saying the answer is somewhere between 6.4, right? Close to 6.4. All right. Okay. Now, so let me just plunge this into Excel again. So if you have Excel, maybe I should share my Excel, guys. All right. Right. Let me just stop sharing over here. I want to share my Excel sheet. I think that'll be more useful for us. Where's my Excel gone? Over here. All right. Are you able to see my Excel, guys? Hang on. One more second. Excel. Guys, are you able to see my Excel?
Yes.
All right. Okay. So what was our word? What did we start off with? What was our first number? We wanted to do 6.2. Starts at 6.2, right? 6.20, and then 6.22, right? So and then what I do is I highlight both of those. I drag it all the way down to 6.4. The formula is equal to, what is the formula, Tavaki? 0.75, right? So that'll be open bracket 0.75 times the cell, which is x, plus 0.25, right? Then we just drag that down, tank. Okay, so where do we hit it? Where's our answer? Our answer 5 is sitting somewhere over here. Can you guys see this? Our answer 5 is somewhere between 6.32 and 6.34. So we now accept that, what we can do is we can try. The best thing about Excel is I can try. What number would sit between 6.32 and 6.34, guys? 6.33, right? Wow. So we learn now that, see, so somewhere over here, 6.33 is giving you 4.99. So it's somewhere between 6.33 and 6.34. So if we take the answer at 2 decimal places, we should accept either 6.33 or 6.34. So our answer is somewhere over there. All right. Okay. Okay. Now, so our final answer, where's my Word document? Our final answer sits between 6.33 and 6.34. All right. Okay. And either of them will be acceptable. All right. Okay. Maybe 6.33 was below the mark, so we will. So we take 6.34 as the answer. Okay. For this example. All right. Side example. This was a side example. All right. Let's now come back to our. Let's now come back to the original problem. Okay, let's return back. Okay, return back back to the problem. All right, guys. Now, what is n? What is n? Okay, so we do a table. That's the whole idea. We have to do a table. You can't do this particular problem without a table. All right, we can't do this particular problem without a table. All right, so what we do is we have to give different values of n. We have to give different values of n. Sir, confirm by solving the equation. You can't solve. Yeah, Salome, you're talking about the side example, eh? All right, guys, let me just finish off. We want to give n, and we want to find the dollar value, right? We want to find what is this p given a? Yeah, want to find p. All right, so let's try what was in our earlier approach. In without the interest, it's 3.7 years, right? So what we do is let's try 4 years, 4.5, 5.0, 5.5, 6, right? All right, guys, and then yeah, we'll stop over there. Thank you, Salome, but we'll finish off this particular lecture next week. It'd be good if you guys could solve this in intervals of 0.25, right? 4.5, and then we'll finish it off next week. Thank you for attending this morning. We will see you guys in next week's lecture when we finish off this particular problem. All right, that's it for this morning. Thank you for attending, and please note, study hard, and we have an exam, midterm. I mean, our end term exam next week, valued at 6%, and that'll be on Friday from 9:30 till 12:30, and you have a 1 hour short test time, but the portal will be open in that 3 hours. There will be no lecture next week Friday. Thank you so much. We'll see you on Monday. Goodbye.